Hello, my name is Madeline Brosky. I'm a junior geology major, and today I will be presenting my ongoing honors thesis titled Investigating Volcanic Eruption of the Ethiopian Plateau Flood Basalt in Relation to Past Climate Change, authored by myself and my advisor, Dr. Nihid Ghani. The Ethiopian Plateau in East Africa underwent a widespread flood basalt volcanic event around Oligocene time, covering an area of over 500,000 kilometers. This volcanic event was followed by numerous younger shield volcano building episodes in the Miocene and Pliocene times, as well as continental rifting. The goal of this study is to characterize the composition and texture of the basalts, understand their geographic distribution, and interpret the general volcanic history of the region. On the right, you see a generalized geologic map of the Ethiopian Plateau. And here is the abstract for my project. The study area is located within the Ethiopian Plateau in East Africa and is part of the East African Rift System. The plateau is comprised of shield volcanoes that erupted in conjunction with rift-forming episodes, covering an area of over 500,000 kilometers. Due to the relatively young age of the volcanism and the favorable tectonic conditions present, a complete record of the volcanism is available for observation. On the left, you see a digital elevation model of the study area. 12 basalt samples were collected from the plateau in order to create thin sections to characterize their texture, mineralogical composition, and degree of chemical alteration. Petrographic microscope and scanning electron microscope results were combined with the basalt extent map to visualize magma source and spatial variation of magma composition and nature. Also, Sentinel-2 images were analyzed via SNAP software in order to visualize the extent of the eruptions. At the bottom, you see a workflow model of our project. Sentinel-2 images are comprised of 13 different bands that represent different wavelengths. The two images you see here are two different combinations of bands that form RGB images that show the extent of the basalt with the lavender color. These two images here are thin section pictures of the basalt, left being plane polarized light and the right being cross polarized light. These thin sections show plagioclase feldspar in a flow-aligned texture. Here are two more thin section images, these showing an olivine glomerocrystal. These images also show plagioclase feldspar with other minerals, but these exhibit field vesicles, also known as amygdules. The round brown areas are the field vesicles. And lastly, this is a close-up of one of the field vesicles that we are able to observe. And in this picture, you can see very clear zoning that has taken place. Next, we use a scanning electron microscope, which scans a focused electron beam over an area in order to create an image. And signals from that interaction of the electron beam and the sample can be used to obtain compositional data. The image on the left was one of the field vesicles that we used the scanning electron microscope on. And these four spectrums show the changing composition from the center out to the edge of the amygdala. Results of the thin section petrography indicate that the basalts are composed of plagioclase feldspar, olivine, and opaque minerals that we saw in the thin sections. The textures of the samples included porphyritic, glomeroporphyritic, flow-aligned, amygdaloidal, and poikilotic. Within the lava flows, vesicles and cavities have been observed. These vesicles have been filled with secondary minerals that are zoned based on the composition of the hydrothermal fluids. Ongoing, we are continuing thin section, petrographic, and scanning electron microscope analysis with both the field vesicles and other minerals that we find in the thin sections. We also anticipate being able to do some geochronologic dating to understand the ages of the basalts. Our end goal is to understand the nature of volcanic eruption in the Ethiopian plateau and its potential impact on climate change, both past and present. We'd like to acknowledge the National Science Foundation, the American Chemical Society Petroleum Research Fund, Western Kentucky University, and the FUSE grant for all partially supporting this project. Also, Dr. John Andersland for access and training of use for the scanning electron microscope. Also, Kibri Tedesi for assisting in the field for sample collection. And lastly, the Mahiran Honors College at Western Kentucky University. Thank you so much for listening.